Hi, today we're going to talk about the octahedral setup, and we're going to start here with sort of the most common octahedral setup, which is sulfur hexafluoride, which is all of the spots are taken up. So we first need to think about sulfur, and so we have one sulfur, and it has 6 valence electrons, so that's 6. We have 6 fluorines, and that has 7 valence electrons, and that's 42. 6 and 42 is 48. And so we got 48 valence electrons. Now, again, sulfur, too small to violate the octet rule, plus it only wants one bond, so it's not going to be a central atom. Sulfur, big enough to violate the octet rule, and it normally wants 2 bonds, but in this case we can see that it wants 6 bonds. Okay, so the first thing I'm going to do is write my sulfur down, and then I'm just going to put my fluorine around it. 2, 4, 6, 8, 10, 12. And so all I did was put my fluorines around it, and then that took 12, and then 48 minus 12 is 36, and you can kind of see what happens here. And this is why this is the easiest structure to do, is you just go 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and again, and again, and again. And so once we distribute all of those unshared pairs, 36 minus 36 is 0, and we're good. Okay, but this molecule is not flat on the page. Just like the ones we've been doing, we need to draw a 3D model of it. This is perfectly fine as a Lewis structure, and if the question asks for a Lewis structure, you don't need to worry about drawing a 3D model. But if it asks for, an actual model of how that molecule looks, we need to represent something that looks like this. Okay? And this is as far apart as 6 things can be, and it's 90 degrees. So no matter how you look at that, everything is 90 degrees apart. And that's just how far apart they can get. They want to be as far apart as possible. And 90 degrees when you have 6 things, that's where we're at. Okay? So to draw that, put your S, and then go 1 up, 1 down, and then 2 forward, and 2 back. And I'm sorry about the dogs. We'll work right through that. Boy, that's a big one. But it doesn't matter. You need to learn, especially when we're working from home, to go through these distractions. So there's my 3D model, and there are the 2 that are coming out front. Hey guys, shut up! Chance? That's my one dog. And then 2 into the front, 2 behind, 1 up, 1 down. And you can see that that's how that model looks. Okay? There's my 2 in the front, there's my 2 behind, I got 1 up and 1 down. And, you can sort of see the 90 degrees. And then the other thing, let's just do the formal charges. So sulfur is 6, and it has 0 unshared plus 1/2 of 12, which is 6. 6 minus 6 is 0. So sulfur is happy in this case with being in that relationship where it has 6 bonds. And then the fluorine, 7 minus, and then you have 6 unshared plus 1/2 of 2 is 1. 6 and 1 is 7. 7 minus 7 is 0. Okay? So sulfur hexafluoride, we see that formal charges work out well, structure works out well. that's known as octahedral. And if you go a couple videos back when I do the intro, I remind you why that's octahedral, but I can show you real quick here too. So if you look at that, there's a four-sided base, and then you get one pyramid pointing up, and you get the other pyramid pointing down. So you get two four-side base pyramids, and that's why it's octahedral.